Hello there, mathematicians. I am making a video for you right now that my cat just crossed, sorry, into the frame, but about complex roots. And specifically, I have made a video for you about this specifically before, in which I gave you 3 examples. However, later, after I had made that, I decided I had neglected to do one like this. So this is sort of a little annex, if you will, a little addendum to my complex roots, roots basically in polar form, or roots of complex numbers, square roots, cube roots, however you want to think of it. Another type of question, or another way the question might be stated or might be given to you, the information. So this is a particular number, and it's really about how the number's given. Because this number is not given in polar form, it's given in rectangular form, and we're asked to write the answer in rectangular form. If the answer is given in polar form, it's still pretty easy to just change it to rectangular form at the end. But here we have to sort of change it at the beginning and change it back at the end, because the formula, if you recall, looks like this. Actually, that's okay, sorry. Now, I am specifically doing this one in degrees. You can do it in degrees. You can do it in radians. The only thing that changes is the 360 would become a 2 pi. I'm doing this one in degrees because I think the division is slightly easier in degrees, and it won't matter for us because we're not leaving it in polar form. So we're not going to see an angle. So at the end, our answer is going to look something like this. All right, so let's go ahead and start by figuring out, we still have to figure out how to use this formula. So we need to know what n is, we need to know what r is, we need to know what theta is. And right now we don't have it in r theta form. Right now it's in rectangular form with a and b. So we have to figure out how to find r and theta from that. So we can use formulas we looked at before. We could also just graph it and use that. I'm going to choose graphing it for a couple of reasons. One is that we need to know what quadrant it's in. So that when we try to find the angle, we can find the correct angle. The other reason is I want to remind you of how those formulas work. So this is r. So r comes from Pythagorean theorem, legs squared plus legs squared equals r squared. So my legs are a and b. So r is square root of a squared plus b squared, which in this particular case is 6 squared plus negative 6 root 3 squared. And when you work all of that out, it's going to come out to 12. So r is 12. The next thing we have to find is theta. And theta, remember, is the inverse tan of our y over our x. Okay, so that's the inverse tan of negative root 3. So let's think about when tangent is equal to root 3 or negative root 3. First of all, it makes sense that it would be negative because tangent is negative in the 4th quadrant and in the 2nd quadrant. So that answers which one of those we need. We need the 4th quadrant answer. The other thing is, remember that tangent is sine over cosine. So this is the same thing as saying I want to find the value of the tan when the sine over the cosine looks like this. Now in the 4th quadrant, the cosine would be positive and the sine would be negative. So it would be like this. So that's basically the point we're looking for. The point where we have cosine of 1/2 and sine of root 3 over 2, which negative root 3 over 2 actually, which is at 270 plus 30 degrees. It's 30 degrees from here. It's at 5 pi over 3, which is also 300 degrees. So we could say 5 pi over 3 instead. But again, I'm going to use degrees here just because I have to divide, and that's going to make it a little bit easier. So I wrote those in degrees. So my answer for my angle here is 300 degrees. So in polar form, what I have here is my r theta is 12 300, and written as a complex number, that's 12 cosine 300 plus I sine 300. So that's basically what we're starting our problem with. That's where we're going from here. We're going into this formula. And really, we didn't have to write this out, but we do need to know that that's going to be 300, and we do need to know that that's going to be 12. So now we're ready to use the formula. So we are doing, if we look back at the top of the problem, square roots. That means n is 2. Okay, so this is going to be a 2, and this is going to be a 2. And this square root, we really don't need to write a 2 there. The next thing, remember, is that k starts at 0 and works its way up to n minus 1. N minus 1 would be 1. So if k is starting at 0, we need to do it for k is 0, and then n minus 1 is 1. So we need to do it for k is 1. So this was a k, remember? So we're going to do z sub 0 and z sub 1. So that means first we're going to plug in 360 times 0, and then next we're going to plug in 360 times 1. So let's go ahead and look at this. Z sub 0 equals the square root of 12 times cosine of 300 plus 360 times 0 means don't add 360. All over 2 plus I sine 300 all over 2. All right, so that's, excuse me, 2 root 3 times cosine of 150 plus I sine of 150. And let's go ahead and put that in rectangular form right now. Okay, that's going to be 2 root 3 cosine 150 plus 2 root 3 sine 150 times I. Okay, and finally we can simplify that as 2, well, it's not really final. This is negative root 3 over 2 plus 1/2, and that's going to give me root 3 times root 3 is root of 9, which is just going to be 3. Negative 3 plus root 3 times I. So there's one of my answers because that was z sub 0. I still have to go get z sub 1. So I'm going to do the same thing to get z sub 1. Let me give myself a little more paper here. A little more surface. The only difference for z sub 1 is that I'm going to have the plus 360 on there right there. So z sub 1 is square root of 12 times cosine of 300 plus 360 is 660. 660 divided by 2 is 330. Sine 330. So again, this came from 300 plus 360 all divided by 2. And that was 660 all divided by 2. So we have 2 root 3 times cosine of 330. The cosine of 330 is 1/2 plus I times the sine of 330 is, wait a minute, cosine of 330, I got the wrong one, sorry. Cosine of 330 is square root of 3 over 2, root 3 over 2. And sine of 330 is negative 1/2. So when I distribute this, I get 3 minus root 3 times I. And there is my other answer. So those are my two answers for the square roots of the complex number 6 minus 6 root 3 times I. Back up here. Hope that helped in case you encounter a problem like that. Thanks for watching, and I'll see you next time.